Okay, if there is no decimal, no, they are not significant. So a quick review, if anybody's watching this on, because I've got a few students away today. When I wasn't recording, we defined significant figures. They are all the meaningful digits in a measurement. They are all the certain digits plus one uncertain digit, and NYM stands for, everyone? No, yes, maybe. And what do we need to ask ourselves if it's the maybe? Is there a decimal? If there is a decimal, are they significant? Yes. If there's no decimal, are they significant? No. All right, so we are going to go now to page, wrong button. Page 97, 97. And if you want to, you can cover up the right-hand column where it tells you the number of significant figures. You can use your answer key or a book or your hand or something. And we're going to apply these rules here. How many significant figures in 3.217? 4 sig figs. That should be easy because all non-zero digits are always significant. Now, how about 0.023? Do those zeros at the front, are they significant? No, because they're on the left. So we only have 2 sig figs. How about 0.000489? 3 sig figs. Okay. Now, how about 3009? 4, because those are zeros in the middle, and zeros in the middle are, yes, significant. So those are 4 sig figs. How about 402.04? 5, because all the zeros are in the middle, and zeros in the middle are always significant. Now we get to our ending zeros. So we're going to take a look at 3.400. There is a decimal, so are those zeros significant? Yes, so there are 4 sig figs. 400.000. Yes, so there would be 6 sig figs. 3200, there is a decimal. We can actually put a decimal right at the end if we need to. It's not a usual thing. Quite frankly, we would probably prefer it if we wrote it as 3.200 times 10 to the 3, but we haven't learned scientific notation yet, so we will be learning it either later today or Monday, and so we're not going to worry about that just yet. You can put a decimal right there, and that is okay. All right, so that is 4 sig figs. 3,400 with no decimal, however, are those zeros significant? No, so we only have 2 sig figs. 400,000, no decimal? 1 sig fig. And 3,200? 2 sig figs. Okay, and then there's just a little picture of the no, yes, maybe. No, yes, only if there's a decimal. Did you want to try these exercises here and then quickly check with your answer key? Give them a go. Because when you're looking at zeros on the right, they are significant only if there's a decimal. So here there is a decimal, so we say yes decimal, yes, those are zeros on the right-hand side. These are also on the right-hand side of the number, but there is no decimal. So we know that I'm not. Yeah, no problem. I'll be right there. I'm just going to plug in my pen. There we go. Because any zeros to the right of non-zero digits, so that's all of these. Okay. Listen, if you have zeros to the right of non-zero digits, they are all of them. If there is a decimal number. Yeah, it doesn't matter where it is, as long as there's a decimal, they are. Like that.
Yeah. Cool.
Hang on.
There we go. They don't.
Yes.
Hold up for that. Why does your phone look like it's you? Wait, this one, bro. Wait. But it's like after that.
Yes, it's great. Good. All right. Questions?
Got me. I don't count that. You got that speed almost? Yes. I mean, oh, good.
Yeah, all right. Hi. Absolutely.
Oh, I'm not bad. I think you have it. Yeah.
Well, good. All right.
All right.
How are you doing? Yeah. Yeah. How are you guys feeling? If you're not standing, they don't have this. Okay, so which ones are kind of confusing for you? Okay, so what kind of zeros are? The user zero is finally on the left, or on the right, or in the middle? There's a middle, so we look and we say we have N, Y, M. So the ones in the middle are yes, significant. Oh, okay, now I'm 1, 2, 3, 4, 5. See, yeah. We drove that. Good question. Okay. And then if you look at this, we have a 0 middle, so that one is, yeah. And then we have 2 at the end, which are maybe, and then that half was no, is there a decimal? Is there a decimal? No. So are these significant? No, so you can count 1, 2, 3. Excellent. We've got these zeros here, these are on the left. Are they significant? No. And then you guys are going over. We have a 0 in the middle. Is it significant? You guys are going over. Okay. And now we have to look at these two and we say, which ones are on the right and which on the right, it's maybe we have to ask, is there a decimal? Is there a decimal in the number? Yeah, there is. So those ones are. So how many do you have? 5, which is what you got already. So you were correct. Okay. Yeah, I think they're mostly looking good though. All right. I mean, how many are we doing the machine? No. Oh, wait. Yeah. I'm his young lady.
Wait, hold on. There we go.
Are we ready to try some scientific notation? So we can do sig figs with scientific notation. Nobody's answering me. I'm going to say yes. Yes, we are. Okay. Oh, Fui, come on. Yeah. Okay, we're going to be on 1.6b. This is page 108. 108. Okay, 108. So we're looking at scientific notation. How many people have worked with scientific notation before? So maybe a third, a half of you, something like that. Okay, so if you're familiar with this, you can just go try the exercises if you want to. If you're not, we're going to learn how it works. Basically, when we have scientific notation, we write a number. Okay, this is either called the mantissa, which is just a fancy word that I kind of liked because it was like just a neat word, but you can just call it a coefficient because that's probably more familiar for you. And then we have a times sign. I would really prefer the times sign over a dot because dots tend to look like decimals, yes? And it gets confusing if I have two things that look like decimals. So if you wouldn't mind writing times, I would really like that. So let's not do the dot, let's write times instead. And then finally, in scientific notation, we're going to have 10 raised to the power of something, okay? So you need to have, and in fact, maybe I will even highlight this one in a different color because you do need that power, okay? So you need 4 things. Number 1, you need the coefficient. Number 2, you need the times sign. Number 3, you need a 10. And number 4, you need the power of 10. Okay, so 4 things, 4 colors there. Because sometimes I'll get people writing 10 if they just want to multiply by 10. But if you want to multiply by 10, you should multiply by 10 to the 1, which is just 10, okay? So those are the 4 things we need. There's one other thing that we must have to be in correct scientific notation, and that is you need to have one and only one non-zero digit in front of the decimal. One non-zero digit in front of the decimal. So in other words, the coefficient, the mantissa, will be a value between 1 and 9.99. You're never going to have 0.8 times 10 to the 3 or 0.046 times 10 to the 3. You will never have a 0 in front of the decimal. You will also never have 10 times 10 to the 3 or 15 times 10 to the 3. The largest number you can have for a coefficient is 9.99. A few other things. We're going to be moving the decimal place around. The number of places that you move the decimal is going to be the exponent. So if you move your decimal place 3 places, you're going to have 10 to the 3. If you move your decimal place 4 places, you're going to have 10 to the 4. If you move it 7 places, 10 to the 7. If you move it 21 places, you'll have 10 to the 21. Finally, if we have a number which is a large number, and what do I mean by large? I just mean that it is greater than 1. Then the exponent is going to be a positive value, okay? So if we have a number that is greater than 1, our exponent is going to be positive. If we have a small number, in other words, a number less than 1, the exponent will be negative. So you can always refer back to these little rules here if you get confused or if you're unsure what the general rules are. We're going to do a bunch of examples to make this make sense. Okay, here we have 45,000. In the number 45,000, I have not written a decimal, but where would the decimal go if I had written one? It would go after the final 0. This is where my decimal would go because I need to move my decimal so I have one non-zero digit in front of the decimal. That is always our goal. Okay? So I'm going to move my decimal place 1, 2, 3, 4 places over. So now it becomes 4.5. And I'm going to leave these zeros here for now. We'll decide whether to keep them or drop them later. 0, 0, 0. Now, are these two values actually equal to each other? The way I've written it is 45,000 equal to 4.5. No. What I did is I made this number got smaller. Yes? We went from 45,000 to 4.5. So I need to multiply it by something to make it bigger. And in fact, you know what? Maybe I will get rid of the extra zeros at the end. It just clutters things up a little bit. Okay? What would I have to multiply 4.5 by to get 45,000? I would have to multiply it by 10 to the power of 4, or I'm just going to start by writing it as 10,000. Yes? So 4.5 times 10,000 would give me 45,000. And how do I write 10,000 as a power of 10? How many times do I need to multiply by 10 to get 10,000? Well, 10 times 10 is 100. Times 10 is 1,000. Times 10 is 10,000. So 10,000 is 10 times 10 times 10 times 10, right? So this would then be 4.5 times 10 to the 4. Yes. Yeah? You're good? Okay. Now, do we want to be writing 10,000 and then 10 times 10 times 10 times 10 every single time? No. So what we can do is instead we can say, I moved my decimal place 1, 2, 3, 4 spaces. 1, 2, 3, 4 spaces. So my exponent is going to be 4. Then I have to choose, is it a positive 4 or a negative 4? Well, 45,000 is greater than 1. Therefore, the exponent is going to be positive. You can follow that rule or you can just understand. Do you know what I mean? Like if you really understand what's going on with your exponents, you don't have to just blindly follow this rule. But it can help you out if you're not quite getting it right away, okay? So that's how we do that, and this is our final answer in scientific notation. Ooh, now we need to look at significant figures. Remember we had 45,000. How many sig figs in 45,000? 2. Because remember, zeros on the right do not count if there is no decimal. So there's 2 sig figs. Have I written my answer with 2 sig figs? Does that 4.5 times 10 to the 4 have 2 sig figs? Yes. Okay? When we count sig figs in scientific notation, we just ignore the times 10 to the whatever. It is meaningless in terms of significant figures. For sig figs, in scientific notation, we only count the numbers in the coefficients. So sig figs in scientific notation only count the numbers in the coefficient. Ignore the times 10 to the whatever. Don't try multiplying it out. Don't try changing it to standard notation. Just leave it alone and you're like, okay, this is good. Okay. And by the way, if I start scrolling and you want me to go backwards, don't be shy about saying, hey, don't move it yet. Okay. All right, here's our next example, 3750. We don't have a decimal, but if we did, we would put it right after that final 0 because that's our ones position, is that final 0. How many places must we move the decimal to have one digit in front of the decimal? We need to move it 1, 2, 3 places. 1, 2, 3 places. So we end up with 3, and then our decimal goes after the 3.75. And I guess I would like to ask you right now, are we going to keep that 0 or not keep that 0? Our original number was 3750. How many sig figs here? 3 sig figs. So this here should also have 3 sig figs. Does it have 3 sig figs? Yeah. Yes. So do I want to put that extra 0 on the end? No. Okay. Whoops. And then we have to have times, and then 10, and then we need to figure out our power. What is our power of 10?
3.
We moved our decimal place 3 places, so it is a 3. And is this number greater than 1 or less than 1? It is greater than 1, so our exponent will be positive. So what that means is I don't need to put a negative in front of the 3. I just leave it as normal 3, okay? And then we're done. And if you think about it, did this make sense? If I have 3.75 times 10 times 10 times 10, you don't have to write this part down. That would be 3.75 times 10 times 10 times 10 is 1,000, which would be 3,750. So indeed it does work. You don't need to do that, but it's nice to just see that it does indeed work out. All right, here's a really big one. Do you want to try this one on your own? I know the answer's right there, but you can try it over on the left, cover up the answer, see how it goes. For sure. Did you guys get 5.8 times 10 to the 5? Do you have a question? No, you got it. Okay, cool. If you didn't, please make sure that you like either ask me right now or you can ask me later if you're a little bit shy about it. All right, and because it was a big number, greater than 1, our exponent is going to be positive. Now, here's how to shortcut if you have a really big number, right? Like if I have 296,000,000,000,000, I don't necessarily want to be going 1, 2, 3, 4, 5, 6. Like that's exhausting, yes? And it gets messy and hard to count. So my suggestion would be to count by 3s. So you would go 3, 6, 9, and then 10, 11. So count by 3s and then count any extra. So this would be 2.96 times 10 to the, it's a big number, so it's positive. We move the decimal place 11 spaces, so it's positive 11. So for this next one, we could count 3, 6, and one more makes 7. This is a big number. It's greater than 1. Therefore, the exponent is positive. So this is going to be 7 point, there moves our decimal, 2 times 10 to the 7. Okay, do we need to do example 6 or can we just move on? We can move on. Excellent. Special case, multiplying by 1. Here's a number, and quite frankly, I'm not quite sure why you would need to write it in scientific notation, but you should know how. And the number is 4.6. Do I have one number in front of the decimal? Yes. So I don't need to move my decimal at all. But I still, in scientific notation, would need to write 4.6 times 10 to the something. And if I have moved the decimal place 0 places, it is times 10 to the power of 0. And remember, what does 10 to the 0 equal? It equals 1. Okay? Don't forget. Okie dokie, so really this would be 4.6 times 10 to the, or sorry, just times 1, which is 4.6, which proves to us that that is indeed our correct answer. Special case number 2, multiplying by 10. Well, let's take a look at this. We got 83.4. If we move our decimal over, we've only moved it 1 position, yes? Exactly. So we have 8.34 times 10 to the power of 1. 8.34 times 10 is missing the exponent. So you would not get full credit for that. You would maybe lose a half a mark. Okay? So far, so good? Can we crush out negative exponents before you go home for the weekend? Yes. Yes, we can. Okay, let's go. Working with small numbers. Ooh, look at this now. First of all, let's start by looking at how many sig figs are in this number. 2. 2 sig figs. So we're going to be working with 2 sig figs at the end. We're going to move our decimal 1, 2, 3, 4 places to the right. Okay, 1, 2, 3, 4 places to the right. So it's going to be times 10 to the 4, yes. And because this number is less than 1, our exponent will be negative. So it's going to be 10 to the negative 4. And if you want to prove that that actually equals what we say it does, we can say, well, that's 7.6 times, do you remember what it is if we have a negative exponent? We put it into the denominator. So we would have 7.6 times 1 over 10 times 10 times 10 times 10, which is equal to 7.6 divided by 10,000, which is equal to 0.00076. You don't need to be able to do that, but it is kind of nice to see that it does indeed work out. Yes. Thank you. No problemo. All right, we have 0.049. How many sig figs? 2 sig figs. Is this a big number or a small number? Bigger than 1 or less than 1? This number is less than 1, so our exponent will be negative. So we're going to move our decimal place 1, 2 places. So it's 4.9 times 10 to the, and we need a negative exponent, 2. Are we liking these? Yes. Yes? Fantastic. Now, once again, you can do a shortcut and count by 3s. So for example, number 12, we can look and we can say 3, 6, 9, 10. One more makes 10. So this is going to be 8.35. This is less than 1, so it's going to be a negative exponent times 10 to the negative 10. We do not have time to go backwards today, so let's just assign you some problems over the weekend. I would like to have a quiz on Tuesday on counting sig figs. Okay, ladies and gentlemen, you are going to be doing quiz on Tuesday on counting sig figs. So to prepare for that, page 99 is all about review counting sig figs. Page 113, you're going to be doing numbers 1 to 18. Make sure that when you write your number, it has the correct sig figs. You're going to omit number 9 and 16 because we have not yet talked about overbars. And you'll look at that and you'll be like, I don't know why that line is there. So we'll talk about that next week. Okay? Do you think you could do the quiz on Monday on counting sig figs? I think you could. Quiz Monday on counting sig figs. Yeah. There we go. And if you're not, if you're really not feeling prepared for Monday, then you're going to come see me at Flex on Monday, and we're going to talk about it. And if I can get you feeling better before class, that's great. And if not, you can write it the next day during Flex. Okay, so if you're feeling good by Monday, fantastic. If you're not, don't sweat it.
Where's your calculator go?
Just right in here. Thank you so much. Oh, and just in case, if you want some extra practice, so this is optional, page 117, number 3. That's some more counting sig figs. Yes, for sure.